My name is Ethan. Welcome to my Physics 2212 Lab 1, the electric tape lab. So the purpose of this lab was just to prepare some charge tape and then estimate the excess charge on each piece of tape. So the models used in this lab were Newton's second law, force equals mass times acceleration. That's used with gravity. Um, and the electric force uh, equation for the magnitude of electric force. And then Newton's third law is used as well, because the magnitude of the electric force equals the magnitude of gravity. So as a preview, the charge of each piece of tape is 9.33 times 10 to the negative 11th coulombs. So for the models, the initial conditions. So the system was the upper charge tape, and the surroundings was the lower charge tape and everything else. And the initial conditions were the tape length was 0.2 meters, the tape mass was 0.0002 kilograms, and gravity was the normal negative 9.8 or negative 9.81 meters per second squared. So for the experiment, you got two pieces of tape, 20 centimeters long each. We grab one of them, fold the end of it to make a handle, and stuck it down to a smooth surface. And for the other piece of tape, we made another handle and stuck this tape on top of the previous piece. Then we quickly ripped off the top piece of the tape and hung it off the edge of a desk. And to test if it was positive or negative, we rubbed a pen in our hair and held it next to the tape. And this pen will be negatively charged. So if it attracted, that means the tape was positive, and if it repelled, that means the tape was negative, and it attractive, so that means the tape was positive. And then we repeated the same process, but hung the upper tape across two surfaces, like two books, and then we held the lower tape under it until the upper tape like pushed upward, and then we measured the difference between the tapes for this to happen. All right, so for the code, here we got our initial constants. So that's epsilon naught, gravity, tape length, mass, distance. That's the distance it was for them to levitate. Gravitational force calculation, the electric force calculation by just taking the absolute value of the gravitational force because Newton's third law, and then I calculated Q by doing the electric force formula. I just moved some numbers around in there, and then I just have some graphics down here. All right. So this is the graphic that was produced. Then you can see at the bottom, this is the charge of each piece of tape, and just here's some explanations for the graphics if you want to pause and look at that. All right. So similarities and differences between code and expectations. So differences between real data and computations may be caused from estimation of mass, because we assumed the mass was 1 gram per meter of tape. And possible sources of error include measuring the tape incorrectly, incorrectly estimating its mass, and incorrectly measuring the distance between the two tapes when levitation occurred. And that's very possible because it was hard to measure that distance correctly. All right, so what if and why? So the question is, what if electrons had a positive charge and protons had a negative charge? Would this cause a change in the observations? Well, no, the observations would not change because like charges would repel and unlike charges would attract when it comes to the tapes. And why? The why question is, why is it important to handle the charged tapes as little as possible? Well, that's because when you contact the tape with your hands or anything, it'll allow electrons to flow from the tape or from your hands to the tape, and it'll just neutralize it. All right, so to conclude, the charge of each piece of tape is 9.33 times 10 to the negative 11th coulombs, and the tape was positively charged. So, all right, thank you for watching, and have a good one.